Alright, our next video here is Heron's formula. This is a formula that we'll use to find the area of any triangle, provided that we know all three sides. So it doesn't have to be just a right triangle, right? So if you remember, our more basic, more familiar, more common area formula for a triangle is 1/2 base times height. But let's say that we didn't really know the height of this thing, right? That's when we can use Heron's formula. Alright, so the formula is pretty simple. Looks complicated, but it's not that hard. We're going to assume that the lowercase letters a, b, and c are the three sides of the triangle. So they go right here, here, and here. Alright, we'll introduce this new variable s, which is the semi-perimeter. So you take all three sides, add them together, and divide that by 2. So you'll put s in 4 spots in your formula, and you'll just take the big square root of that. Alright, so if you haven't copied that down, please pause this. But I have 3 examples to go through. Number 1, find the area. Find area. Okay, so the first thing we want to do for Heron's is check to make sure we have all 3 sides. We do. So then we're going to find the semi-perimeter. The semi-perimeter is a plus b plus c, all divided by 2. Alright, so that'll be, let's see, 28 and 10 is 38 over 2. So S is 19. S is 19. That's our semi-perimeter. Alright, the area formula, Heron's formula tells us we need to use 19, and then we need to use it again, and then we need to use it again, and then we need to use it a fourth time, I should say. So this right here is going to be one of the sides. It doesn't matter which one. This will be the other, and this will be the last. So that's Heron's formula right there. Alright, then you go to your calculator, and we can enter this in all at once. So let's see here. We've got big square root. So we're going to get big square root, and our semi-perimeter is 19. Open 19 minus 15. Close. Open 19 minus 13. Close. Open 19 minus 10. And you don't even have to close the end of that. You'll get an answer 64.062. So we can type that in all at once and get 64.062. And that's it. This is an area, so we are in square yards. Square yards. So that would be the area, like I said, the area of this triangle. Not too difficult, especially when you have all 3 sides to begin with. But in example 2, we're not going to have all 3 sides. So let's see how to tackle something like this. It's important that you've watched Law of Sines, Law of Cosines before you watch this video, because in this case I have no idea what that third side is, so we need to use one of those laws to find a missing piece of an oblique triangle. So this is a case where we have side, side, and an angle in between. This is side, angle, side, so that is definitely Law of Cosines. So here we go. We'll call this lowercase d, which is across from capital D. So we're going to use d squared is equal to 6 squared plus 7 squared minus 2, 6, 7 cosine capital D, which is 83 degrees. Alright, there's nothing wrong with using the law of cosines with different letters than A, B, C. Right? We just know that they correspond. Alright, capital D is across from lowercase d, capital F, lowercase f, and so on. Alright, so here we go. We're going to enter this whole thing. Let me move it over a little bit so I can see it. We're going to enter this whole thing into the calculator all at once and see what we get. So we have d squared to start. So at the end I'm going to have to do the square root. So I'm going to do that first. And then I'm going to go 6 squared plus 7 squared minus 2 times 6 times 7 times cosine 83. Okay, I'm going to check to make sure that that's okay. Didn't make any mistakes, and I'm good. 8.647. So D is 8.647. 647 inches. But that's like, even though we took it out to 3 digits, it's not exactly the answer, right? So I'm going to show you that when you go now to find your semi-perimeter, all right, we're going to use 6 plus 7 plus that. So I'll just put plus that answer all over 2. So we use our calculator to our advantage. We're going to go 6 plus 7 plus, and now here again we'll use the answer function, so it's copying the answer down from the previous calculation. Close that parenthesis. Really important that you close that parenthesis, if not you'll get the wrong answer. So our semi-perimeter is 10.823. S is 10.823 inches. All right, but it's not really 10.823. It's actually like all these decimals and more, but we'll just focus on what our calculator can do for us. All right, so now we're going to go to our Heron's formula. So we're going to go S, which is 10.823. I guess I'll just write that down. 10.823. And we're going to write it again. Minus 6. We're going to write it again. Minus 7. And we're going to write it a third time. Minus our third side, 8.647. Close the parenthesis, and we're good to go. But that's kind of crazy to type into your calculator, right? We don't want to type that whole thing in. So again, I'm going to use my answer function. Watch this. So I go second square, which will give me a square root. I'm going to bring that answer down as my semi-perimeter. The calculator is using that answer right there as a nice copy paste. I'm going to open. I'm going to do answer again. Minus 6, close, open, answer. Minus 7, close, open, answer. Minus the third side, which is up here. We'll just type that in. As many decimals as you can see there. We want to make sure that we're using as much precision as possible. And I'll check to make sure I didn't make any mistakes. Answer minus 6, answer minus 7, answer minus, yeah, that's fine. So our area is 20.843. The area using Heron's is 20.843. And it's a square inch. So again, if you didn't use the calculator's answer function, then you're probably getting something that's a little bit off of that, right? So be careful. Try to use your calculator to your advantage. Last one. In example 3, our objective is the same, to find the area. We don't have this side, so we need to find that first. All right, this is a, let's see, side, side, and an angle that's not in between those sides. So this is definitely a law of sines problem. So we're looking for, ultimately we're looking for like lowercase h, right? To find lowercase h, we're going to need to know capital H. To find capital H, we want to first find angle P. So let's do that first. So the sine of angle P over lowercase p is equal to the sine of capital K over lowercase k. All right, so multi-step problem. So we're going to go and take this and move it up here. So here we go. I'll clear this screen out so it's not so crazy. Let me move this over so I can see a little bit better. So we have, all right, so we have, let's see, 13 sine 50, close, divided by 24.2. Enter. So that'll give us 0.412 essentially. So the sine of capital P is 0.412, but there are more decimals. We'll use our calculator. Now we're going to hit inverse sine of that answer. and we get angle P is 24.3. So the measure of angle P is 24.3. So that'll go right in here. I'll erase that question mark, 24.3. All right. Next we want to find angle H, so we're just going to use the triangle sum theorem. So we'll go 180 minus these two. And again, I'm using my calculator's ability to copy and paste. So 180 minus that answer minus the other angle, which was 50. Let me make sure. Yeah, it's 50. And that'll give me my remaining angle. Angle, in this case, angle H. So it's 105.7. So the measure of angle H is 105.7, approximately. It's pretty darn close. So 105.7. Now we're ready to find H, lowercase h. So we're going to use, we have all the angles, and we're just looking for that side. So let's just go ahead and continue with our law of sines. So we'll go lowercase h over the sine of capital H is equal to, I'll use lowercase k over the sine of capital K. Alright, now we're just going to take this denominator and move it up here. Just about finished finding what we need to find. Let's move this over a little bit. So we have 24.2 times the sine of our answer. Again, we want to continue to use our calculator's answer function over sine of 50. And this will give us the length of segment H, lowercase h, 30.412. So this little guy right here is 30.412 centimeters. Pretty darn close to it anyway. It has more decimals to it, but right now we'll just write that down on the screen. Okay. So after all that, right, we did law of sines, law of sines. Now we want to actually find our semi-perimeter. So it's going to be the sum of the three sides divided by 2. So again, we'll do let's see, open parenthesis, answer plus 13 plus 24.2 all over 2. And meanwhile, I'm always checking to make sure I didn't make any mistakes calculating this stuff. 33.806. So S is 33.806 centimeters. Once we have S, now we're ready to actually use our Herons. So we go 33.806, and I'll just write answer minus, let's see, our three sides here. We have 13, answer minus 24.2, answer minus the third side was 30.412. That was H. So we typed this all in at once. So let me see if I can smooth this over just a little bit so I can kind of see what I'm doing here. Alright, so I've got big square root, semi-perimeter, which is the answer, open, answer minus 13, close, open, answer minus 24.2. Oops, screwed that up here. Oh boy. All right, when I do something like that, I'm just going to press second enter and then do it again. Yeah, I'm trying to get this 33.806 back on the screen. Let's see if this will do it. I don't think it will. No. All right, no big deal. We're actually going to, let's see here. I'm kind of stuck here, but I'm just going to improvise. 30.412 plus 13 plus 24.2. So this is my semi-perimeter, 33.806. All right, there were more decimals to that, but for our purposes, since I'm kind of running low on time here, I'm going to just use that. And that's our semi-perimeter, so I want to go second square, or give me a square root. And I'm going to enter that in right there. Open. I'm going to try to be a little bit more careful here. I think I was going too fast. Minus 13. Close, open, answer, minus 24.2. Close, open, answer, minus 30.412. And there we go, 151.432. Square centimeters, and we're finished. All right, what I'm going to do now is I'm going to pause this. I'm going to go back and I'm going to calculate using all the original numbers. Right? You notice I made a mistake there in my calculations, so I lost some of the decimals. But I'm going to pause this, calculate it, and then I'll press play. I'll press record again, and I'll give you what the actual answer is. All right, so I did all my calculations and didn't get an answer that's that different, thankfully. So the more precise answer, if we're splitting hairs here, would be this one. But you can see it's only off by a thousandth, tenth, hundredth, thousandth. Yeah, it's off by a thousandth. So it's not that big of a deal. Right? But sometimes those decimals, especially when they get carried over differently, right? If you remember, this answer 24.3 was actually really close to what it actually was. We didn't actually have to estimate that too much. If you remember, that was 24.9981, and it was really close to 0.3. Sometimes if it's not that close, then your final answer is going to be significantly off. So in any event, that's all I have for you. That's 3 examples on Heron's formula. One involved just the regular Herons where we have all 3 sides given. This one we had to do some law of cosines. This one law of sines, right? But we use this formula anytime that we are looking to find the area of any triangle, provided that we know or we can find the lengths of any of the sides. All right, so it's pretty useful, right? It's one of those things that, you know, if you know it, it'll definitely save time on a test. If you don't know it, you might be able to get by with doing some other stuff, but it's definitely one of those useful tools to have on your side.